Hey everybody, this is Larry, this is Miko with Q4 of the weekly contest 302, minimum deletions to make array divisible. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, the first thing I would notice is that you're trying to return the minimum number of deletion so that you have the smallest element. So given that this sentence, my first inclination is to sort nums, right? Because basically what you want to do is you want to get, just in case it gives me a binary searchable number, it's not true in this case, but basically a number that when you go for, or just left to right, allows you to figure it out, right? Like, you're trying to get the smallest number, you try the smallest number one at a time is what I mean. And then the second thing here is kind of a little bit of constrained looking, which is noticing that is 10 to the 9, right? Each number could be 10 to the 9. What does that mean? Well, that means that in a weird way, it does eliminate a lot of possibilities on things you can do. I actually misread this as 10 to the 5th for each of the numbers instead of just the length. And actually, I would say I think that would have made for a little bit more of an interesting problem. Not that much more, but a little bit more, only in the sense that then more algorithms became possible, because now you can do sieve, you can do some kind of prime factorization based on sieve and stuff like this, and then maybe there's a more interesting math that you can work out in that way. However, given the way that it is now, because it is 10 to the 9, there are very few there are very few things that you can do, really, to be honest, in a weird process of elimination kind of way. And what I mean by that is, okay, given number 10 to the 9, how do you factor it, right? Well, just the n square root algorithm, right? Square root of n algorithm. And if you have n square root of n or square root of 10 to the 9, and there's 10 to the 5th numbers, that's always 10 to the 4.5 times 10 to the 5. That's going to be 10 to the 9.5 or something like this, right? And in that sense, you're like, well, that's already going to be too slow, so you're not even going to factor the number by prime factorization, or by like the counting up to the square root of this number type of strategy, right? And so there are a lot of ways you can have done it. Here I know that right now I'm not really describing the proof and the solution yet. I'm just kind of going over, these are my thought process on how I solve this problem, and these are the thought process that maybe a lot of people got it in 2 minutes. I got it in about 3 minutes. These are the thought process that goes through my mind, a little bit on the meta level for sure, but that's how I think about it. And an additional thing to the contest, not gonna lie, is that I did see that a lot of people got it, so I was able to YOLO a little bit, if you will, and kind of on my solution. But all that said, it's just about like, if I were to try to solve this problem without all these kind of meta observations and not regular observations, if you will, I would the first thing, like I said, would be sorting it by nums, right? So that we could try, okay, it's too good again. Well, second time cannot be. Is 3 a possible answer, right? So forth. So then, and everything to the left of it, you delete, right? And that's the minimum number deletion. And then now, the numbers to the right is the slightly more interesting part. One way that you can think about it is just, like I said, prime factorization. But keeping in mind that you have to go into all of these, right? So let's just say, and I think as soon as you draw it out, this becomes a little bit clearer anyway. Without all my meta stuff to kind of whatever. But yeah, you just prime factorize, right? 3 and then 3 times 5, and here you can kind of see that you kind of see that if a number has to divide into all these numbers, well, you can just take the common factors of this. In this case, this is just a 3, right? You kind of see it that way. And it turns out, and here you could see the other one as well, maybe. No, this is less interesting. I think everything just 2 times 3, 2 times 4, 2 times 5. Yeah. And in this case, you know that the solution has to be a factor of 2, right? Because 2 factors in all of these, or like, yeah, 2 will divide into all these numbers. This is not a great example, only because, well, 2 is a prime, right? And also this one as well, because 3 is a prime. But let's say you have some weird numbers where, let's see, right? Let's just say we have this, but a little bit more. Let's just say you have 2 times 2, right? Then now, the common factors are 2 times 3. And that means that the number that divides all these numbers will divide 6, right? Or 2 times 3, because if it divides that number, then it by definition divides all these numbers. And that's pretty much really all the proof you need, I think. I mean, obviously you can make it slightly more rigorous, but that's the idea. And the way to get the common denominator, well, and literally the greatest one, because the greatest common denominator will allow you to have more, will have the most factors to, divide, right? And you could use this with, what's it called, Euler's formula, or is it Euler's formula or something like that for factorization? Yeah, Euler's formula or something like that to count the number of factors or whatever. But the idea is still the same, right? Which is that you want the greatest common greatest common factor, because those would have the biggest factor. And it turns out that GCD is the function that you want, so you just do a GCD of all the numbers. And then once you do that, the code is pretty straightforward. Like I said, we can move the sorting down if you like, but this gets the GCD of all the numbers, and then this is just sorting and then trying each one by one. And that's pretty much it. This is going to be kind of linear time if you don't count bits. It's always a little bit nuanced with these problems, because GCD for example, a big int is not constant, right? So there's some things there. But here, obviously, there's some sorting, so it's n log n. But yeah. Yeah. That's all I have for this one. Let me know what you think. You could watch me solve it live during the virtual contest now. Do index thing. It's just very weird. Okay, fine. Minimum deletion to make array divisible. What does that mean? I don't know why I'm reading it out loud in a silly way. I feel like I didn't look at these for the other problems, but to this problem I did look at this one, so it's a little bit of a spoilery, and I expect Josh to be finished already if I only look at the leaderboard. I'm just gonna look at the leaderboard for fun. Does it even show up? I don't know. Alright, let's just focus then. I mean, this is a reseed, so I don't care that much, but okay, let's actually read the problem first. 2 numbers away, delete any number of elements from nums. Minimum number of digits such as the smallest element of nums divide all elements of nums divide. What does that mean? The smallest element is 2, so then you have to delete 2, and then 3, 4, 3. Okay, what does that mean? Let's see, what do we want it to mean? Think about this. I mean, I feel like there's a couple of ways I can do it. I'm just thinking about. Okay, so there's 10 to the 5 numbers. The numbers can be pretty big. Oh, 10 to the 9. That's a little bit different. I actually misread this. I thought the number could be 10 to the 5th, and I was gonna already did some SIF related things. But because it's not, then we don't do it. But how do we do it then? Well, we just get the GCD, right? First of all, yeah, I mean, okay. I forget whether GCD takes an array in Python. Some languages it does, maybe not in this one. Nope. Okay, fine. Whatever. I forget how I write it. It shouldn't matter anyway. And then now, yeah, just what are we supposed to return? The number? Oh, the number of deletions. Okay. if G, maybe this. I'm a little bit YOLO-y. Yeah, okay, maybe that's right. Ace not off by 1. YOLO, because so many people got it quickly. Maybe you won't. Okay, fine. Some of that is meta, right? Like I probably would have at least like worked out some more examples, to be honest, if I didn't have I did that 6,000 people got it during this one, and if this had refreshed, yeah, I would have been Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later here from DC. Bye bye.